hopefully this will be an interesting webinar and might give you some ideas of how to use different creative approaches depending on what you have in your school. So, obviously you just heard a little bit about me, but I thought I'd give a little bit of an intro as well. So I have previously been a teacher, so I have taught computer science and IT at a couple of different schools actually. So I've worked at rugby school and I've worked in some independent girls' schools in the UK as well. So I've worked quite a lot with girls as well as in a mixed school. Um, Obviously, I've written some books. So here are the books that I've written, and partly we're going to have a look at some of the resources from those in this webinar today. So we'll sort of dive into those a little bit further. So that was a very exciting part of my career. And I've done quite a lot of writing, sort of technical education writing, both for students to work independently on the resources, but also for teachers. So I've trained lots of teachers in different things. Mostly sort of computing rather than IT, but a bit of a variety. And I'm also quite passionate about open source software. So having the ability to use software that is open source. So usually that means free, but you can also see the code and you can, if you want to, contribute to the code. So one of the things that I found difficult when I was teaching was that my students wanted to develop programs with a GUI, so with a visual sort of interface. So I decided to create a library called GUI Zero, which allows you to create that kind of interface in Python very easily. And then that proved to be quite popular. So that's a thing that I've worked on. But I'm really quite passionate about making things open and making things accessible so that people can use them no matter what resources and no matter their sort of technical setup within the school. So hello and welcome. Just before we go into some of the more detail, I wanted to talk about the challenges that computing and IT teachers face. And it very much is computing and IT or digital literacy, that kind of thing, because these books cover both of those. So there's a sort of a mixture of computing topics and IT topics within the same chapter often. But I think this particular subject often faces some challenges that maybe other subjects don't that you have in school. So obviously, to be able to use different software in your lesson, it has to be available and it has to be installed. A big consideration for that can be the cost of the license. So are you able to get the particular software that you want, or is it too expensive? Does it depend on the kind of school that you are, what the company's licensing policy is, or is it perhaps free software? You may find, and this quite often happens in schools, that you have different versions of software, and sometimes they can be quite out of date because that's the version that was last bought, or it may be that they are, if it's a piece of free software. So for example, in the school I'm currently at, we have the Adobe PDF reader, but it's an incredibly old version because that's what happens to be installed on the network. And so some of the features, like annotating, are missing. So sometimes that can be challenging if you are using a resource and it says, use this piece of software, but you've got a slightly older version. I know that data protection regulation is difficult often for schools. And obviously, I know that we have people here from a wide variety of countries, so that's going to vary from country to country. But if you are signing students up for an account to use a piece of cloud-based software, then it may be that your school requires you to check the particular policy of what's being done with that information before you get them to sign up, either from a data protection point of view or from a safeguarding point of view. So that's obviously a thing to be aware of. Hardware, I think we all sort of have completely different hardware within our schools. Some schools may have the most latest sort of up-to-date kit, really fast computers, maybe desktop computers in a suite. Some schools may have laptops, and they are in a sort of a standard teaching room, and then you distribute your laptops. Some schools may have tablets, some schools may have bring your own device. It really varies quite a lot. And again, we can have the same sort of financial challenges with updating that hardware and that kind of thing too. But also things like cameras or microphones or other peripherals that you might need to use. Have you got those available? Do they exist? I remember when I was teaching before, we had significant challenges with something as basic as headphones, because we kept buying headphones and they kept getting broken. And actually, my solution to that, bizarrely, was to buy cheaper headphones, because then it mattered less if they got broken, and they got broken with about the same frequency as the more expensive ones. But just sort of challenges like that, which can make things a little bit more difficult for a computing and IT teacher. We've also got AI. So obviously AI is a big topic at the moment, and this is a piece of technology that is evolving very rapidly, as I'm sure we can all tell, each time they release a new GPT, a new version, a new AI image generator, that kind of thing, it becomes better and better. But I'm not sure that education and the general skills of teachers are going at the same pace as the evolution of the AI, because obviously people are really busy and not necessarily able to spend large amounts of free time getting up to speed with, the latest thing. But the challenges are not just sort of technical challenges. Something I found when I was teaching was that often my subject, so whether that was computing or IT or a mixture of both of those, was based on either a very small amount of teaching time, compared to some other subjects, or it may be that you have a rotation-based system. So quite often I was in a rotation where students would come to me for a term and then they would go off and do, I don't know, design technology or food technology or something like that for another term, and you would only see them for one term throughout the year. Some schools like to implement IT across the curriculum. So they like to ask different subjects, can you please teach this particular part of IT in geography? Can you teach how to make graphs in maths and that kind of thing? So you don't necessarily have the control that you would have if you were teaching as a discrete subject, if then the subject is sort of pushed out to different subjects across the curriculum. And obviously, this can be quite a frustrating one, but you may end up that you're competing with other subjects in a kind of way. So there may be different options for the students to take. They may be opting to do computing on IT or instead of something else. Or there might be other sort of co-curricular things. So a challenge might be making the subject sort of marketable, making it look attractive to students and making them understand exactly what it is, without just thinking, well, I don't want to become a programmer when I grow up, so I'm not going to take computing. So we obviously have a lot of challenges. That doesn't mean to say that we can't have an amazing time teaching computing and have some really valuable lessons for the students. So in this webinar, we're going to look at 4 different things. So I'm going to dip into different examples from the books through each of these topics. So we'll start with project-based learning, then we will look at unplugged, and then we'll talk a little bit more about software and finish with confident use of AI. So let's get started. So project-based learning is the first thing that I wanted to talk about. And just as a sort of, I'm sure most people have got a good idea of what project-based learning is, but in case anyone's sitting there sort of going, what is project-based learning? Oh dear. Basically, it's combining lots of different learning objectives, possibly from different topics and different areas, into a larger project. So most of the, in fact, all of the chapters that are in these books, they are sort of like a little project. So at the end, the students will have created something or will have done something that has encompassed all of the learning from that particular chapter. And I think that's quite a nice way to work in terms of, especially if you have like the students, like I mentioned, for only a small chunk of time, because then you can have a nice discrete chunk of learning and then you can then move on to something else, and it sort of wraps it up as a whole quite nicely. You can probably see from the chapter 4 that I've got on the screen just here, chapter 4, How Computers Work. This is an example project from the Stage 9 book. So this is one of the chapters. And if you look at the part that says, in this chapter you will, you might notice that there are things from a huge variety of different areas of the curriculum. So there's a little bit about fetch, decode, execute cycle, so the actual sort of hardware, and Boolean expression, so the logic behind that. But then we also look at operating system and utility software, and converting between digital storage units. So it's not that we're just spending the entire unit on one particular topic. They're all combined together, and then combined with some sort of more digital literacy based things. So the IT part might be using your skills to make a poster. And then to showcase the poster is using a different skill again. So having to explain what you have created to other people and to show off, like it was in this particular example, like a science fair type setup. So I think throughout basically the projects and throughout the books, there's a theme or a series of themes for the pedagogy where we've tried to use certain ways of learning in a variety throughout the project. So those ones are classroom talk, so discussion, talking in the classroom, not just being the teacher as the sort of the sage on the stage kind of thing, having the ability for students to consider and to talk and to think about the material. Showcasing, as I've already said, which is this feature at the end. And I think this is often a sort of neglected part of computing and IT, because everyone creates things and then it's sort of, oh, and that's the end of the topic, which is great because the students have learned those skills. But actually, I think a really important part of computing and IT work is being able to explain what you've done and to talk about it. And certainly that's something that if students are wanting to go into a career in IT is certainly going to be a really, really valuable skill, and a very marketable skill, not just to be able to do the technical parts, but to be able to fluently and accurately and appropriately to the audience talk about what they've done, rather than it just being sort of an internal thing. And then if I move on to the next slide, and I'll talk about these bits in a minute. So another one of the pedagogies that we've tried to put in is creativity. So obviously trying to make students able to be creative with what they do. We don't want to just have do this, now do this, now do this type sort of work. We want them to be able to put their own stamp on it and to be able to be creative and to be able to add things. So right at the bottom here, for example, there is a little AI generated picture of a monster as part of a presentation, and this logo is also designed by the student. So the project is to get them to design a game, and it also then brings in, so the project based part brings in other parts of the curriculum, such as looking at the different payment models for apps and for games that they may be aware of on their phone, but also bringing that together with the creative part of creating your own idea. We try to bring in real world context when appropriate. So the part on the left, which is from book 8, is again, and this is one is actually part of a slideshow as well, where students create a virtual tour. So they could create, this one is particularly a virtual tour of a school, but that is open again to real world. So they may think, okay, well, in my local area, there's a really brilliant museum, or I really love going to this park, or there may be some particular thing that your area is famous for. So then they can use that real world example to bring that into their work and to make it something that appeals to them and is important and interesting to them, rather than just being told do this particular topic, that kind of thing. Practical skills. So you can see there's a graph there that has been created of animal sightings on the sports field. So this is a skill, like I mentioned earlier, sometimes in different subjects you may be asked to use IT or expected to use IT skills. So this is a practical skill that they have learnt, creating a graph for this particular topic, but that could be transferred to all sorts of different subjects and all sorts of different areas. And then just to mention, there is a workbook. So as part of the series, there's also this workbook, which when you are working through the project, so it's not just here's a thing to do, there's also different questions, there are different reflections, and all of the answers are provided for you as the teacher. So it sort of brings different elements of thinking, doing, and that kind of thing into the project. And the final sort of pedagogy that I have not mentioned so far is unplugged. So we'll talk about this in a bit more detail coming up, because that's one of our other topics. But just having basically offline, so not needing to use a computer as part of the process. So, for example, this is a project from in fact, the final project from book 9, and part of the process involves the students designing what they are going to do just on paper. So thinking about what the design for their particular this particular project is to create a sensor and to display the information. So the example given here is a sensor for a plant which senses the temperature and then displays either a smiley face or a sad face, depending on if the temperature is appropriate. But they've had to do some kind of design work, not just for the programming elements. So you may think, okay, well, I'll think about designing maybe a flow chart or something for designing my program, but also designing, there's a bit about the ergonomics, the design of what the rest, if you like, of the project is going to be like. So it's not just here's the programming part, it's okay, well, how does this work for the users? How do I consider who's going to use this particular piece of technology and make that work for them? And then obviously they've created the actual flower here with a lolly stick to stick into the plant pot, and then it can stay there and monitor our plant. So often I think that I find that people say to me, oh, computing, that's just staring at a computer, making a spreadsheet, typing in programs, that kind of thing. It's not very creative. And I would say it's probably one of the most creative subjects. Where else can you create something with absolutely nothing? All you need is a computer, and the world is your oyster. You can create whatever you want. So I feel like projects like this project are probably quite helpful in terms of selling your subject. Having plant monitors sitting somewhere on a windowsill in school, or displaying things like the pictures somewhere that students can see and go, oh, that's really cool. I'd like to make a sensor that senses something, and can be quite useful as a kind of a marketing tool for the subject. Moving on to unplugged, which I mentioned briefly before. So a lot of the time we are learning with computers. So we are learning, so if we do, there's an example of Scratch down at the bottom left. So we're learning sort of about computers with computers, which I guess is the sort of intersection of those two circles. But unplugged learning is learning about computers. So it's entirely possible to learn about how computers work, and to gain very valuable skills without actually having to use a computer. And that's really what this sort of section is all about. So I've put a little example there with the beads, which I will talk about in just a second. Of course, it is possible to learn about computers with computers, but we're specifically talking here about not using the computer at this point. So why would we do this? Well, unplugged learning helps to develop computational thinking. So there are various papers available that talk about this, but broadly, I think the findings are that it positively affects learners' computational thinking skills. So things like abstraction. So if you think of abstraction as filtering out the details that we don't need, to be able to focus on what's necessary, sometimes that's hard to do if you're using a computer and you've got all this sort of shiny stuff going on. If you've just ended up with a piece of paper, so for example, a map, there was a map of the school that I work in, and it was an architectural map. And this was the map that was sort of given to staff, and it had all kinds of things on this architectural map, like electrical points and the exact position of trees and all kinds of things like that, that was not at all of any use to me as a new member of staff. All I wanted to know was, where are the toilets and where's the English department and where do I get my lunch, that kind of thing. So I created from this more detailed architectural map, I created a much simpler abstraction map, which contained the useful information that was relevant. I don't need to know where the electrical sockets are or exactly what tree is where, but I do need to know certain things. So that sort of takes away the distractions, basically. It also helps with algorithmic thinking, so thinking things through, problem solving. So trying to get students to plan programs is what's the word? A constant problem, basically. So I always used to find that they were very, very unwilling to think before they started to do. And I think that taking away the computer element from that helps with the actual thinking part, and it takes away the option to start writing some code or to start drawing a poster, and to make them actually think, okay, well, what would be a good idea? How can I plan this? How can I solve this problem? And also pattern recognition and design-based thinking, another couple of things there. So as an example, this role play is from one of the books as well, and the subject is about an echo check, which is a fairly sort of abstract notion for a 12-year-old or 13-year-old. That's not something that they will necessarily come across in their day-to-day life. So why would they have any thought or any relation to that? Well, if you get them to actually do it, so they have to do the echo check themselves and act as the computer, then that suddenly becomes real, and it increases their engagement with whatever is going on in the concept that you're trying to teach. And hopefully that means that they understand it on a more conceptual level, rather than just remembering, this is what an echo check is and what it does. Also, obviously, unplugged learning is helpful if there is a limited amount of access to hardware. I know I've worked with some schools in Kenya and South Africa where there are not a lot of devices available, and they obviously have to be shared. And then sometimes there's no internet, for example. So it can be super helpful if you haven't got access to devices all the time. Maybe you have to share them between classes, that kind of thing. You can still do meaningful learning without having to need a device or a particular device. So this example here is, there's an activity where they transmit a message similar to the echo check message, but slightly different. And then they have to translate that into colors on a page, and it ends up as a picture. So this webinar sort of was titled of how to do things with the technology that you have. And actually, you don't need a huge amount of technology to be able to teach quite a lot of computing. So for example, counting in binary, you can do this using just hands. So you can ask the students to label their hands, either with, obviously you could write on their hands, but you could put stickers on hands, and then you can really easily and quickly illustrate the point that you can count in binary by labeling the place values on the individual fingers and then getting them to hold up the different fingers and then adding up the numbers. So that works quite nicely. I've also done that quite successfully with cake. So we had some muffins, and we had some chocolate muffins and some vanilla muffins, and then you have to make different binary numbers by laying out the muffins, and obviously they were quite enthusiastic about that and then wanted to eat the muffins afterwards. That worked pretty well. Um, you can add sort of more visual things to encourage people to get involved in the first place. So sometimes you get students who are quite reluctant and they sort of think, oh no, this is not for me. I'm not a computing kind of person. But the engagement to sort of draw them in the first place, you can grab their attention and then sort of sneakily feed them the vegetables of the computing. So this example here is a bracelet made out of beads with their name in ASCII. So if you're teaching ASCII characters and how letters are represented on a computer, then you can represent that in a very visual way by getting them to create a bracelet with the letters, with the appropriate ASCII codes for their name, and they can literally wear their name. And then if somebody says to them, oh, what's that bracelet? Well, that's my name, and it's written in ASCII, and that's how computers represent numbers and letters and that kind of thing. It might be a little bit more difficult if you're teaching Unicode, but it certainly works quite well in ASCII. And then the bottom one, the heart picture, was part of an exercise using run length encoding. So run length encoding being where you can compress something that you're sending. So this image, you could say it's got, so on the top left, there's one white block. So that could be one white. And then you could say, instead of saying black, black, you could say two black. So that would be two, one white, two black, and you can see this row not so much compression going on here, but once you get to this row, then you've got 1, 2, 3, 4, 5, 6, 7 red, and then the next row is also 7 red. So that saying 7 red is compressing compared to saying one red, one red, one red 7 times, if that makes sense. So then you're using a visual representation to show that this compression is happening. So just sort of bringing those kinds of things in. And then bringing in relating to the real world concepts as well. So lots of students will have been to a swimming pool. They will be familiar with the sort of basic rules of how they are supposed to behave in a swimming pool. So bringing this into Boolean logic relates it to something that they have experienced. So you must shower before you enter the pool, and no running are rules that they're already familiar with. So getting them to then write a Boolean expression that says yes to showering and no to running, then it's something that they can relate to. So, but you don't need to have a computer to be able to do that. Something that's quite nice to do is you can get them to do these kind of exercises unplugged, so on paper, and then you can get them to check their own answers. So there are loads of logic gate simulator pieces of software, cloud-based software, websites, that kind of thing. So you can get them to check their own answers after they've done the unplugged learning, if that's what you want to do. I'm just trying to get rid of my annotations. I've just realized there's some annotations there. The other one here is the image that I've made here is from an AI image generator. And at first look, it probably looks like somebody typing on an old-fashioned typewriter type thing, bit of a steampunk vibe going on there. But you can see that actually, if you look a bit closer, the person's fingers look a little bit odd, and the letters are not all letters and that kind of thing. So another way of working in an unplugged sense is that you can use something that's computer based, but then use it as a stimulus to prompt the discussion or prompt the reflection. So you could say, okay, how do we know that this is an AI generated image? What clues are there, so getting them to think about that kind of thing, or what do you think about this? Should people use AI to generate images? Is this going to cause people in creative careers to lose their jobs? That kind of thing. So there's lots of ways that you can go that don't actually require you to get the students using a computer. So yeah, that's sort of unplugged. Now I'm going to move on a little bit and talk about choosing software. And this is something, the little cartoon is something that I think about quite a lot. So obviously, as teachers, we're all super busy, and it's very tempting to just carry on doing the same thing that you have been doing for a really long time, because changing your scheme of work or changing the way that you work or the piece of software is really, really difficult, and requires quite a lot of effort and time. But it is something to think about. So in terms of choosing software, obviously you're going to be considering the software that you already have, the software that you're already working with. But like I mentioned sort of briefly earlier, you may find that once you've been using that software for a little while, maybe it's starting to get a little bit dated. Maybe you might want to start thinking, okay, is there anything else out there? And just checking that you've got the thing that is the most relevant. Obviously, cost is going to be a big factor in this consideration. So what budget do you have? What is available to you generally? What does the school already pay for? That kind of thing. Your hardware is also very relevant. So if you only have tablets, then obviously you can only use software that's available on tablets. Desktops, you may have more choice, possibly, depends on what kind of things you want to use. If it's bring your own device, you may want to use sort of more cloud-based things. And that also brings in technical barriers. So thinking about, if I'm going to use something that's cloud-based, okay, it's already set up there. I don't have to install anything. I don't have to go and ask my technicians and technical team to sort anything out. It's just there and I can use it. That you may have a brilliant uh, way of working with your technical team and you may get on super well with them, or you may find that sometimes you unfortunately get blocked. So it depends on that. The level of knowledge required. So it can be quite scary to learn something new. I remember when I first started teaching Python and I didn't know Python, and over a summer holiday I had to learn Python and then go and teach it to my classes. So whether you're able to quickly get up to speed with a piece of software or not. Um, and then these two, which I've mentioned before, data protection. So again, that will vary from country to country. But what are the sort of controls? What are the regulations for any data that you're putting in, any data that your students are putting in, and what data is being harvested about you as a result of you using this piece of software? So this is this is sort of a table that I've drawn up, which is to do with video editing software, because I know that a lot of different people are using different things, and they're not necessarily the things that I would be using in my personal life compared to what the students are using. So a choice might be something really sort of proprietary, such as Adobe Premiere, which maybe, if you're very lucky, your school has. It's quite expensive. You can use it on desktop computers. You need to have a relatively decent computer to be able to use it, because it will use a fair amount of RAM. And I would say it takes a little bit of getting used to, but pretty decent in terms of data protection. However, that may not be the best thing for you. It may be that it's too expensive. It may be that you can't run it on the computers that you have. It may be that you don't want to be sort of that technical. So you may want to choose something else. So have a look at the different things that are out there. So iMovie is free if you have iPads. It's there already, but it's only on iPad. It's pretty straightforward to use, and it doesn't go and share your data with anyone else. But there are starting to be these other pieces of software that students are going to be using. So on their own devices, they're going to be making their TikToks, they're going to be making Instagram reels and that kind of thing, using software such as CapCut and InShot. So both of those are available on tablets. CapCut you can actually use in the browser as well, or you can use it as a piece of software on a desktop computer. And with this kind of model, so CapCut and InShot, they are free-ish. And I say ish because InShot has some sort of in-app purchase type things. CapCut again is free, but there are sort of things that you can pay for, the more premium things. But a lot of the problem with using this kind of thing in schools is the data protection aspect. So what are they using your data for? And you have to look quite carefully at the licensing agreements to find out whether that's something that's appropriate for you and your school. So they're fantastic pieces of software. Students will be familiar with them, but is this appropriate for what you need to do? You need to check. Obviously, there are other pieces of software available too, but just a sort of an illustration of the different things to think about. So when you are choosing the software, for example, there different ones that we have suggested in the guidance. So in the teacher's guide, which comes for each of the books, there's a whole sort of teacher's guide here with lesson by lesson what you should do and all the answers and everything like that. But there's also guidance about what software to use. And when I was writing these, I thought quite carefully about making sure that all of the activities are available to everybody. So it's possible to do the activities without having to pay for a specific piece of expensive software. So you may not have Microsoft Publisher, that's fine. You could use Canva, you could use Google Slides, you could use PowerPoint. Sometimes you are able to sort of flex what a piece of software is meant to be used for, depending on what the outcome is. So you could potentially make a poster in PowerPoint, even though that's not what it's sort of intended for. Or you may already have something like Adobe Illustrator, excuse me, that kind of thing. So they are all deliberately designed to be accessible no matter what you are using. Same again, image editing. A lot of people previously will have had Photoshop, but there are sort of free alternatives that are springing up. So this one is Pixlr.com, which is free, and you can use. There are a variety of different ones that are able to be used for the same purpose. It just depends what's right for you, considering those different factors. But the suggestions are given, basically. And then finally, moving on to using AI confidently, both for students and for you as a teacher. So obviously this is a relatively new area. And I'm just putting basically the same kind of Venn diagram up here because I think there's a difference that should be called out between teaching about AI, so about how AI works. So for example, up in the top left here, we have the self-driving vehicles. So we're thinking about how machine learning has been used to analyze the various inputs from the cameras, from the sensors to make it possible for vehicles to drive on roads, hopefully safely by themselves. And then there's a difference between that and teaching with AI, so using AI in whatever it is you're learning. So for example, here is an image generated using Adobe Firefly, which is an AI image generator. That might also extend to, for example, you creating teaching materials using AI. So there's two different aspects here. There's teaching about AI and how it works and teaching using AI. And you can also obviously teach about AI with AI as well. So you can do both. So my experience of AI is that it is an incredibly good collaborator. So for the most part, I use it as if it's somebody who I am working with. So collaboration, if I want to know something or if I want to sort of flesh out an idea or a prototype something, then I may well go to an AI. Usually I will use ChatGPT, but there are other ones, Gemini, Claude, that kind of thing, and use it as if it was somebody who is working with me to help me to refine my ideas. Um, Also to help me to not spend an awful lot of time searching through websites. Is incredibly efficient at finding the answer to a technical question. How do I do X? How do I do Y? What it's really poor at is just doing my work for me. And I think that's a thing, sort of a core thing that students fail to understand is it's not um, a substitute for doing your work. It's something that you can collaborate with um, to make your work better. But if you don't retain the control, if you don't steer the process, then you're going to fall over. And it's sort of, imagine if you are working with another student on an assignment, if you just ask the AI to do whatever the assignment is and then just think, okay, well, that's fine, I'll just submit it. The other student may have done something completely that you don't agree with, that's wrong. They may have made a mistake. And AI, obviously, as we probably all know, will quite frequently make a mistake. It will hallucinate. It will tell you things which are just not true. So you have to be the one that's sort of driving it. So I think that's my sort of pitch to the students. Um, and again, it's not the whole task. So for example, here is a project from stage 8, which is creating a targeted advertisement for a new lunch project. And this is not the whole project. So part of the project, the students will be using a spreadsheet to decide on costs and to figure out how much it's going to cost for this particular lunch idea that they've come up with. But then they are asked to use AI to come up with an image of this product. So it's using it as part of the project rather than the whole lot. And you can see here, here's an AI generated meal that I created with my AI image generator of my tofu and noodles. But not just having the AI part of it, we're also talking about legal and ethical knowledge. So that we're talking, bringing in that sort of copyright aspect of it. We're bringing in the online safety aspect of it, because obviously an AI image generator could potentially, I mean, lots of them will have guardrails on, depending on which one you use, but it could potentially show something that's inappropriate. Um, this sort of showcases the prototyping aspect that I mentioned before. So you can ask an AI image generator to generate something. If you don't like it, you can ask it to change it, that kind of thing. And then bringing in the real world context. So what do professional designers do? How is this used in the real world? How is this similar to what I might do when I go to work? So that's part of that project. And then there are activities which use reflection. So we're not just using the tools, we're actually asking the students to think about, okay, can AI replace creativity? What impacts do you think that AI image generators have had, for example, rather than just hear the thing, off you go and use it, thinking about, okay, well, should I be using this? When is it appropriate to use this? Maybe what could go wrong? What could go right? That kind of thing, actually bringing that part of the discussion in. So rather than shying away from it and going, no, don't use AI, that's cheating, that's plagiarizing, encouraging them to think about it as a collaborative tool and something that can enhance what they're doing, but with its own limitations. And then going on to using AI for teachers, I think something that I would flag up is that not all AI image generators, so we're talking specifically about image generators at this moment, they're not all equal. Definitely please check, if you're going to use one, what the usage agreements are. So some of them will say this is not to be used with children who are minors, and that the age for whether somebody is a minor may vary depending on which country you're in. So some of them just say minor, some of them will say a specific age like 18 or 13 or that kind of thing. Some of them will explicitly say what they use the inputs to do, whether they train their model with them or not. So Adobe Firefly, I think, is one of the most appropriate ones for education because it's trained the model on images that Adobe owns. Some of them are trained on images that are scraped from the internet, and they could be using people's work without their knowledge or without their permission. But I think also something that's really important to flag up is that they give non-deterministic results. So if you type something in and you get a particular result, you won't necessarily get the same result if you type in that same exact thing the next time, which is something that was quite surprising, I think, initially. Also, they may not do what you expect. So this image that I've put here is actually an image which I generated last year because I wanted to celebrate Christmas and I wanted to celebrate by sending a nice festive picture to my friends. And I have a husband and two children and a cat, and I asked them to generate a nice image of a family with a husband, a wife, two children, and a cat. And this is the image that they came up with. Um, the cat is not one of my children, so you can sometimes get some slightly bizarre results from the AI. I've mentioned about checking the usage agreement. I sort of briefly touched on what was the training data, but also I think you need to be aware of bias. So this is actually an activity which was written by an ex-colleague of mine when I worked at the Raspberry Pi Foundation. But the activity trains a model by showing it lots of different apples and tomatoes. And so it says, okay, we need to distinguish between what's an apple and what's a tomato, which is great if you show it lots of green apples and lots of red tomatoes. But then what happens is if you show it a red apple, it will say it's a tomato. Because if your data was biased, i.e., it only showed the data was only trained on green apples, it will have certain opinions about what is an apple, and then if you suddenly then go, okay, well, here's a red apple, it will be very confused. So similarly, that kind of bias can appear in sort of image generation, it can appear in LLMs, that kind of thing. So be aware of that as a sort of a background issue. And then something which I think is very interesting with the use of LLMs, and I think that we have seen sort of people getting emotional support and advice from LLMs, that kind of thing. And that can be very, I don't know, easy to fall for in a way, the fact that the LLM will just agree with you. So here is an example of something which I typed in to ChatGPT, and I typed in both different perspectives. So I typed in the perspective of an employee who has been told off for their boss for coming in late to work, and the LLM immediately responded with, "Oh yes, that's really frustrating, and you know how mean of your boss." But then I also typed in from the perspective of the boss saying my employee was 10 minutes late and it's having an impact on my business. And then obviously the LLM also agrees with the boss and then says, yes, that can be very disruptive, sets a poor example. So I think that the response that you get from an LLM, whether that's you using it to sort of generate teaching materials or to ask questions or whatever it is, be aware that it will agree with you. That's what it's sort of set up to do, and it will say nice things like, wow, that's a really insightful question, that's really clever, you know, that kind of thing. You can tell it not to do that. So you can say, I want you to be completely objective. You can say, I want you to be unpleasant, I want you to, you know, ask it to have a particular personality. But at the end of the day, it is still not human, it's not sentient, it doesn't agree with you, it's been set up to work that particular way. So being aware of that is, I think, quite a big consideration, both for you, but also for imparting to students when they're using AI. So just bringing together, and obviously I want to leave a little bit of time for questions too. Project-based learning, I think, is a really interesting and exciting way to work. It increases engagement because you have a variety of different topics and different skills, and it really lets you get into the real world examples and allow the students to apply what they're learning to things that they care about. Unplugged learning can be really helpful with that too, because it means that you don't have to necessarily use computers or have particular pieces of hardware, software every single lesson, and also allows students to boost their skills by taking away the sort of distractions around the edge and just go in with the sort of thinking part. There's a lot of software out there. There's a lot of cloud-based software out there, but be careful about what you choose. So you may want to choose things that your students are using because that's the latest kind of thing, that's what they're familiar with, but be careful about what their data is being used for and what you're signing up for. Um, I would say that AI is incredibly useful as a collaborator. So I think it's difficult to imagine a world now that will not have AI in it. So I think we need to be preparing students for that world, but not as a replacement for thinking and using their brain, but more as a sort of a sidekick kind of role. And that reflection and thinking about what they have seen, what they have generated, is this appropriate? Is it correct? Does it have mistakes? Is really, really important. And for you as a teacher, being aware of the non-deterministic nature of AI so that you won't get the same result from the same input ever, and be aware that it can be biased either in your favor, or if you're using something like a model that recognizes, let's say, on a webcam or something like that, there can be bias in different ways depending on the training data. There can be bias based on the training data in LLMs. In any sort of model which has been trained, the data that goes in will affect what comes out of it. So hopefully that's been a sort of a whistle-stop tour. I will say any questions, and I will just pop this slide up here there so you can see the different ways of staying in
Okay,
touch.
so we're going to move over to some questions. We do have some in the Q&A box, but do keep submitting them in the Q&A box, which is at the bottom of your screen. So one of the questions we have here is, do you have a tracking or monitoring tool that helps monitor learners' progress in computing across the year?
So in the books, there is a certain way of getting students to reflect on what they've done. So there's the assessment checklist, which I will hold up here. You probably can't see, but there is a whole checklist that the student themselves has in a workbook, that they can then go through and decide, have I done this, have I not? And obviously the teacher can then see that and to keep track of it. I think everybody tracks their actual the results for their class in a different way. So I don't think there's a specific tool necessarily. I mean, some people prefer to do that on paper in a mark book. Some people will do it in a spreadsheet. Some people might have their MIS, that kind of thing. But there's certainly the ability to look at the different parts of what have you learned in each chapter and then sort of tick those off, that's available to you. So you don't even have to think about what are the things that I've tried to, what are my objectives? They're already there for you.
Great. Another question we have here is, in using AI, how will you explain to the students the limitations of using it? Especially students sometimes don't want to think about a specific question, and they just ask the AI straight away, which affects their critical thinking skills.
Hmm. I think showing them. So that's partly why I showed you the example of the apple versus tomato. That is based on a resource called Teachable Machine. So it's a website, it's a web-based resource, and you'll be able to find it fairly easily if you type in Teachable Machine. And you can actually show them by training that model yourself. So it's set up so that you can train the model, that it will generate bias if you don't provide it with a wide range of training data. So you can do all kinds of things. You can do things like training it with hand gestures, like a thumbs up or a thumbs down, or I don't know, other things like that, or different cards you can hold up, that kind of thing. And you can show it that if you don't provide good quality training data, then it will not provide a good quality result. Similarly, you can show it that certain types of questions will not necessarily result in good answers. So, for example, if you're teaching about Boolean logic, if you try to get an LLM to answer a Boolean logic question, it will make a big mess of it. It will often get it wrong, but it will sound incredibly confident that it's correct. And you'll think, hang on a second, that's not right. So you could potentially do that. I mean, if you do it live, beware, because obviously it being non-deterministic, you may not get the result that the same result that you got when you practice. So you may want to sort of do it yourself and then take a screenshot of what came out. But sort of illustrating that point with, here's an actual example of an LLM making a mistake would probably be a good idea, I would say.
Perfect. I also have a question. So some teachers will be teaching students that have English as a second language. So do you have any advice for teaching computing for ESL learners when there is quite a lot of subject-specific language?
Yes. So sometimes, depending on what you are teaching, there are different things that you can do. So, for example, for Scratch, if you're teaching Scratch, there's the ability to change the blocks into a huge variety of different languages, which can really help to generate the mental model of what's going on with the program using the student's first language. And then once they've built up that mental model, then speak and switch back to English, and then they're able to more easily access the resources, the sort of worksheets and the lessons, that kind of thing, that are in English. Um, Once they've sort of built up the model, the concept inside their head. Also, there's terminology. So each topic has got the key terminology sort of brought out here. So if there's anything in particular that's a specific term for that subject, or for that topic rather, then that's called out there. But also, when I was writing all of these books, I think I had definitely in the back of my mind, I've written quite a lot of resources for international audiences. So um, a lot of my work has been for people to use throughout the world, and has been used for people throughout the world. And as a result of that, there are certain things that, I try to avoid. And I know that the Flip Computing team, who wrote the earlier students' books as well, do the same thing, to make sure that both the examples that are given are relevant sort of universally, hopefully, but
Mhm.
also avoiding things like idioms and things that might not make sense for students who have English as an additional language.